Okay, in our last video, we left off with this equation. I've tried to write it a little bit neater. I realized that the y and the g kind of look similar. But we got to the condition where we're trying to find t. Right? We've got it appearing in two spots here. We were able to get rid of y and y naught because we assumed that they're the same. After some amount of time, the distance, overall distance is 0. It goes up, the projectile goes up, and then comes back down to the ground, right? So we're assuming that that is the same distance. So there's no difference. All right, from here, there's two approaches. You could use the quadratic equation, but there's actually something easier. So let's put them on the same side. So we have 1/2 g t squared minus v initial y t equals 0. Okay, we're trying to solve for when we're trying to solve t such that we get 0 in this case, right? So we're trying to solve for t here, essentially cases that give us 0. So we can factor, let's see if it'll let me scroll here. We can factor out a t. So 1/2 g times t minus v naught y times t equals 0. So I just pulled a t from here and a t from here and brought them outside. Okay, we know essentially that this will equal 0. And remember that this 0, by the way, is delta y, right? This is delta y. We said that y after some t minus y initial is 0. They're the same, right? So this is delta y. So we're solving for t such that the change in y is 0. Okay, well, obviously a t of 0 here will equal 0, right? 0 times this stuff is equal to 0. The other situation, though, is when this term here is equal to 0. Right, if that stuff is equal to 0, then it'll be 0 times the time equals 0. So let's solve 1/2 gt minus v naught y equals 0, right? Because that case will give us the 0 that we're looking for over here. So we have values for all of these except for t, so we're solving for t. So 1/2 g of t equals v naught y, and then let's bring the 2 up and the g down, so t equals 2 v naught y over g, right? So from here, we know that v naught y, or my initial velocity in the y direction, was this value, 4.24. So plugging that in, we know that g is 10 meters per second squared. So t is equal to 2 times my v naught y, which is, what did I say, 4.24 meters per second over 10 meters per second squared. This should have a negative sign in it. I'm guessing I lost a negative somewhere along the way in this video, but we know that the time's not going to be a negative value. So I'm guessing that I've lost a negative sign. If we go back, I'm sure we could find it, but don't worry. If you get a negative time, just know that, hey, that's not correct. You can't have a negative time in these problems. So it's going to be a positive number. So we'll just disregard the negative. That's something that's nice about physics, is you can reason your way with the sign. So 2 times 4.24 meters per second divided by 10 will give you the answer. So let me crunch that. So 2 times 4.24 equals this, divided by 10. All right, 0.848 seconds. So it's not in the air for very long at this speed. So right here. So we get that t is equal to 0.8, what did I say it was? 848. 848 seconds. Okay, now what do we do with that number? Like this problem up here was not how long does it take for it to hit the ground. It was where will it land? Well, if you've done the problem previous to this, the airplane problem, it's the same thing, right? Now I'm going to use this time, right? Take the t and multiply it by v naught in the x direction. That will give you the displacement in the x direction, right? That will give you the change in x. So v naught x happens to be the same as v naught t because it's a 45, 45, 90 triangle up here earlier. Way up here when we did this, right? Whenever we broke velocity into its vectors, if I can draw a triangle, it's not sideways. Having a tough time with this writing pad. Try it again. Okay. That's better, but not the best. Okay, so we said that the velocity was 6 meters per second this direction, and we said that v naught y was equal to 4.24 because we did some trig. This was 45, right? Well, same thing. If I want to find this, it's just cosine of 45 times 6 meters per second. If I want to find v naught x here, right, this for in SOHCAHTOA, we've got that cosine of theta is adjacent over hypotenuse, or v naught x equals, sorry, let me go back. I jumped a step on you. Okay. Cosine of 45 degrees equals v naught x over 6 meters per second. So 6 meters per second times cosine of 45 degrees will give you v naught x, right? And cosine of 45 and sine of 45 happen to be the same. So this will give you, sorry, I didn't mean to put a negative sign. This is positive, I don't know. I accidentally touched the pad, I guess. This will give you the same value, 4.24 meters per second, okay? So it's simply 4.24 meters per second times the time that it was in the air, which was 0.848 seconds. Seconds cancel, and we'll get the distance that it traveled. So 0.424 times 0.828 is 0.35 meters, roughly, which isn't too short. I think did I read the right number off? Try that again. Sorry. 4.24 times 0.828. Should be 3.5. Okay, it's 3.5 meters. All right, to summarize, the approach that we took in this problem was we figured out how long the projectile was in the air, right? And we applied that to the horizontal component of the velocity v naught x. Okay, we had to use some trig to figure out v naught x and v naught y. Okay, I'll see you in the next video.